Now today I have a very interesting topic for you. It's titled numbers, and the only prerequisite for this video is that you have to know that 2 comes after 1 and 3 comes after 2. Everything else will be taught in this video. Now the first thing we want to discuss in this video is a few confusions people have about numbers. We have all heard these words: integer, we've heard real number, we've heard natural numbers, we've heard of decimals, we've heard of whole numbers, and you've probably also heard of irrational numbers. Rational and irrational numbers. I'm just put irrational numbers here. One important thing to understand, the first point I would like to make in this video, is that these 6 words are not interchangeable. The integer is not the same as real number. Not all natural numbers are integers. Real numbers and whole numbers are not the same thing, and these are not all irrational numbers. So general confusion is people often think that all this means the exact same thing. These are all different ways of saying a number. You can say natural, or you can say real, or everything's just an integer. And then sometimes if you see a decimal, it's a real number. But the thing is, these are all different, and they all have minute differences. Some people choose to neglect these small differences because the differences are very, very small and insignificant. But in this video, to lay the basics for future complicated subjects, I would like to elaborate on the specifics of each number property. So what I would like to tell you right now is that these six are all properties of numbers. Let's have a diagram showing what is where. Which of these words are positioned in the definition of numbers itself. So when you think of numbers, you probably think of 0, 1, 2 and 3. But there is so much more going on in between these numbers. So all numbers are defined as real numbers. Every single number, whether it's 1 or is it 0.1, is it 2 or 0.003, they are all real numbers. Square root of 3, they're negative 2, they're all real numbers. So these real numbers come up into 2 different categories. Number 1 is rational, and the other one is irrational. We can go to irrational later. Let's look at rational first. Rational numbers are any number basically. We have 1 over 2, negative 3 over 7, 46, 0.17. These are all rational numbers. See, some of it are fractions, some of it are decimals, some positive, some negative. All these are rational numbers. And within rational numbers, there are integers. Integers are whole numbers. Integers could be 0, negative 3, negative 2, negative 1, 0, 1, 2, 3. These are all integers. These are whole numbers on the real number line. And within the subcategory of integers, if these are integers, there is another smaller category called natural numbers. These are natural. Natural numbers can only be positive. 1, 2, 3 and so forth. These natural numbers are positive integers. These are purely integers. So within the subgroup of integers, we have natural numbers. And this entire subgroup is rational numbers. Entire subgroup is called rational numbers. And then we come to irrational numbers. Irrational numbers can be the square root of 3, the square root of 5, 3 over pi square. So let's say we have the value of pi, or we have a square root, They are all considered irrational values, irrational numbers. But don't please understand that these are all part of the real number line. They all fall in the real number line. So we have cleared up one confusion where each number type sits on the real number line. So we have rational, and within rational we have integers, and within integers we have natural numbers, and then we have irrational numbers that constitute square roots and pies. So now let's see, between rational and irrational numbers, what differentiates a rational number from an irrational number. See, rational numbers and irrational numbers. In rational numbers, every real number, first thing to understand that every real number has a decimal representation. So the most common ones are 1 over 2 is equal to 0.5. You would have learned this quite some time ago. And one thing we don't know after 0.5 is the infinite number of zeros. But we can choose to ignore them because they place no value within the number itself. And we have 2 over 3. 2 over 3, which in decimal form is 0.666666, on and on. And you probably know that we can write, it's a recurring decimal. It's recurring. Recurring means we put a line at the top showing that this number is recurring. And we have so many more, even the more complicated ones, like 157 over 495, which is 0.3171717, and the 17 is recurring in this, so 0.317, and on top of the 17 we put the line showing it's recurring. Okay, and irrational numbers, let's choose any random irrational number, perhaps, yes, the most common one, pi, which is 3.14159265535. Okay, and it goes on and on. It's a huge value. And then we have the square root of 2, which is 1.41421356. Okay, so now why have I separated them into two subgroups? So to identify a rational number and differentiate it from an irrational number, we have to see whether there are recurring decimals. See, in 1 over 2, the recurring value is obviously 0. There is a recurring value. And 2 over 3, the 6 is recurring. In 157 or 495, the 17 is recurring. There's always a recurring value, whether it's 0 or any natural number. But in irrational numbers, it's a completely random set of numbers after the decimal point. It can be in any order, it can be of any type. So that's what separates rational from irrational numbers. Rational numbers have some form of recurring decimals after the decimal point. But irrational numbers are completely random. The decimal representation is non-repeating. If the number is rational, then its corresponding decimal is repeating. So repeating decimals and non-repeating decimals are what separates rational from irrational numbers. And now we commonly deal with rational numbers, and irrational numbers we are not usually recommended to leave irrational numbers in their original form. We do not usually convert them to decimals because the decimal place is very big and can affect future calculations when we come to the final answer. Now, we have understood the types of numbers. Now let's put everything into the real number line as I write it over here. The center of the real number line is 0. Okay, 0 stands for something having no value. I mean, well, it does give value to other numbers, but every single number on the number line is placed with respect to 0. So every number is measured in its size, in its strength, by how far away it is from 0. So the further away the number is from 0 to the right side, the bigger it is. The further away it is from the left, the smaller it is. So every number is put with respect to 0. So it's the most important number in the number line. And then let's have it here. Let's draw a line so we can map it out. And this side, as you probably know, and is the one thing you're supposed to know to understand this video, we have 1, 2, 3, 4, 5, and all the way until positive infinity. An infinite set of numbers going towards the right. And towards the left, at the end of the left, we have negative infinity. Negative infinity can be the largest negative number there is, and it cannot be represented by the ordinary number system, so we place the infinity sign. And on this side we have -1, -2, -3. So those towards the left and those towards the right. So these, as I mentioned before, are natural numbers. They are natural numbers, and these are ordinary integers. So within 4 and 5, for example, within 4 and 5 we have 4.1, we have 4.2, 4.3. Within 4.1 and 4.2 we have 4.11, 4.12, 4.13, and so on. Within 4.11 and 4.12 we have 4.111, 4.112, 4.113, and so on. So there are an infinite number of real numbers between each number in the number line. These are all real numbers. So if they ask us to list out all the integers between 1 and 5, we list 1, 2, 3, 4, and 5. So keep this in mind, On the other side, between -1 and -2, we have -1.1, -1.2, -1.3, -1.4, and so on until -2. And within this, obviously, we have -1.11, -1.12, and so on. And this breaks down further and further. So that leads us to the final confusion between integers and real numbers. Integers are a subgroup of real numbers. Okay, everything is defined by the word real numbers, but integers are a subgroup of real numbers. So that brings us to this question, the confusion most people have, the confusion that we have to clear up by the end of this video. So when the question asks, list all the integers between 1 and 5, we list 1, 2, 3, 4, and 5. These are the integers, these are the whole numbers between 1 and 5. There are no decimals to be seen. It's a very simple question. But let's say we have list all the real numbers (1 and 5). This is a question you would have never seen before, because this is impossible to answer. Basically, any number, any decimal can be a real number. We can have 1, we can have 1.01, we can have 1.001, we can have 2.1, 2.2, and 2.3, and so on. So this is impossible. So it's basically 1 to 2. There are millions, billions of numbers between 1 and 2. So it goes all the way from 1.1 to 1.000000001, and it goes on and on. There is a huge number of real numbers between 1 and 2, and if you count to 5, it's basically impossible to answer this question. At least you cannot answer this question within mathematical reasoning. So you never see this sort of question before. So in conclusion, let's just do one final summary. We have real numbers as the huge category of all numbers that can be represented by modern mathematics. So within real numbers, we have two, rational and irrational numbers. Rational numbers, we have any number with recurring or repeating decimals, so 1 over 2, -3, 3 over 7, 46, 0.17, and rational numbers. Under rational numbers, we have integers of -3, -2, -1, -5, 0, 1, 2, 3. And within integers, there's another subgroup called natural numbers. Natural numbers are positive numbers within integers. So 1, 2, 3. There are exactly 3 subgroups within rational numbers. And on the other side, we have irrational numbers. Irrational numbers have non-recurring non-recurring decimals. So that usually includes a pi value, which is 3.1415, or square roots. They're all irrational numbers. So this is the confusion that we are supposed to clear up today. All these words are not interchangeable, and that is what I would like to point out today. So I hope I've cleared up your confusions about what each of these mean and how these can be linked together and related together and be applied into the number system. And this will lay the foundation for a lot of new topics we'll learn in the future. And while it may seem negligible, it is absolutely not. But these differences are what define mathematics. So in the future, when you learn more complicated topics like calculus and trigonometry, you will have to know the small differences between numbers, and that's why I decided to do this topic today. It is of absolute importance to know these differences.